Hello viewers, welcome to the video series of solid question paper. 2C question is, if y is equal to log of x plus root of 1 plus x square, prove that 1 plus x square yn plus 2 plus 2n plus 1 into xyn plus 1 plus n square into yn is 0. So this carries 5 marks. So what we'll do is, first we'll take y is equal to log of x plus square root of 1 plus x square. Then we'll differentiate it one time and we'll again differentiate two times, and we'll differentiate n times by applying the Leibniz theorem. Then finally we'll get this expression. So we'll apply Leibniz theorem. So differentiate the y is equal to log of x one time, two time and n times by applying the Leibniz theorem. We'll get the answer. So the solution is consider y is equal to log of x plus square root of x square plus 1. Call this as whole square. Call this as equation number 1. Now differentiate with respect to x. What we get is y1 is equal to, so this is something like something raised to the power. So differentiation is power into log x plus x square plus 1 into the differentiation of log of x plus square root of x square plus 1. So 2 times the log function into differentiation of this log function. So what we get is y1 is equal to 2 log x plus square root of x square plus 1 into differentiation of the log is 1 over the given thing is x plus x square plus 1. Log differentiation of x is log x is 1 by x. What the function is, that only will come in the denominator. 1 by x plus square root of x square plus 1 into again differentiation of x plus square root of x square plus 1. So y1 is equal to 2 log x plus square root of x square plus 1 into, so I'll write this here, x plus square root of x 1 over is there, this is, I'll write it in the denominator. Differentiation of x is 1 plus differentiation of a square root of x. So we know that differentiation of square root is 1 over 2 root x. Differentiation of square root of x is 1 over 2 root x, 2 times into whatever given. So the differentiation of this is 1 over 2 times 2 root x into, again if we differentiation of x square plus 1 is 2x. So differentiation of square root of x is 1 over 2 root x into, again the differentiation is 2x. Here 2 and 2 gets cancelled. So y1 is equal to 2 log x plus square root of x square plus 1 divided by x plus square root of x square plus 1 into 1 plus x by square root of x square plus 1. So y1 is, if I take here, we'll take the LCM, 2 log x plus square root of x square plus 1 divided by x plus square root of x square plus 1. So what we'll do here is, here we'll take the square root of x square plus 1 as the LCM. So what we get is square root of x square plus 1 plus x, which gets cancelled with the denominator x plus square, which is same as the numerator. So what we are left out with this 2 log y1 is we are left out with 2 log x plus square root of x square plus 1 divided by square root of x square plus 1 in the numerator. So this is our y1. So what we'll do is we'll send this with the LHS. So what we get is square root of x square plus 1 into y1 is equal to 2 log x plus square root of x square plus 1. So what will we know that log of x plus x square plus 1 whole square is y. So what we have here is log of x plus 1 whole square. So squaring on both sides we get that value, entire value as y. So what we'll do is we'll square on both sides. Squaring on both sides. So what we get is x square plus 1 into y1 square is equal to 2 square is 4. 4 into this entire thing whole square. But we know that the value is y. So x square plus 1 y1 square 4 into this value is y. This is from equation 1. The value is y. Look at the equation 1. So this will be same as y. So we'll reduce it to this form. Now again we'll differentiate. We'll bring it to the LHS and differentiate one more time. y1 square minus 4y equals to 0. So what we'll do is we'll differentiate with respect to x. So if we differentiate with respect to x, what we get is this is two functions differentiation is, so this is 1 plus x square as it is, this one as it is. Differentiation of y1 square is 2y1, differentiation of y1 is y2 minus plus y1 square as it is, differentiation of x square plus 1, second function. So these are two functions u and v. So keep the first function as it is, differentiate the second function, plus keep the second function as it is, differentiate the first function. This is how the differentiation of two function takes place, minus differentiation of 4y is 4 is a constant, differentiation of y is y1. This is equal to 0. So what we observe is we have this y1 term, 2y1 and 2y1 is common. 2y1 and 2y1 is common. I will take that 2y1 as a common factor. So remaining is 1 plus x square into y2 plus x into y1 minus, here also 2y1 is common. So minus 2 equals 0. So dividing by 0, or if you send this to the RHS, 0 by 2y1, 2y1, 0 by 2y1 is 0. So this term goes. So what we are remaining is 1 plus x square into y2 plus x into y1 minus 2 is equal to 0. So call this as equation number 2. Now what we'll do is differentiate this equation 2 n times by using Leibniz theorem. So we'll use Leibniz theorem to differentiate this n times this equation number 2 using the Leibniz theorem. So we'll apply differentiating n times. The meaning of this is differentiating n times of this function 1 plus x square into y2 plus again this term also differentiate n times x into y1 minus differentiating n times this function 2 is equal to 0. So we'll apply now. These are two functions. 1 plus x square is one function, y2 is another function. So differentiating n times of a 2 function. Let us take this as v and u. So we'll choose v, this one as v, because if we differentiate first time, what we get is 2x, and second time is 2, and the third time the differentiation becomes 0. So it vanishes. So that function we should take as v and the other one as u. So differentiating n times uv function is, Leibniz theorem says nc0 v as it is, v function as it is, write it as it is, and differentiation of y2 function plus, next is nc1, differentiate this is 2x. Now differentiation of n minus 1 times y2 function, here n is there dn, here dn minus 1 of y2. Next time if you differentiate this will become 2. So plus nc2, so you can see it is nc0, nc1, nc2. Again this differentiate this, what we get is 2. Next differentiation n minus 2 of y2. So this is what Leibniz theorem says. Differentiation n times of this expansion is this one. Now we will take this plus sign as it is. Now differentiation of x y1. Here also 2 function is there. X is there, y1 is there. We will take this one as v. So expand using the Leibniz theorem. nc0, take it as it is, differentiation of n function of y1 plus nc1. What is the differentiation of x is 1. 1 into differentiation of n minus 1 yn. Next the differentiation goes to 0, the function vanishes. So till then we have to expand, minus differentiation n times of a constant is 0, which is equal to 0. So what is Leibniz theorem says is, 2 function is there, choose the function which vanishes or goes to 0 as v function, nc0 v function dn yn. So nc0, nc1, nc2. Next is differentiation of, write v as it is, 1 plus x square. Differentiation of 1 plus x square is 2x. 2x differentiation is 2. Then it becomes 0. So leave that term. Next differentiation of y2, n times y2 as it is, dn y2, dn minus 1 y2, dn minus 2 y2. One term becomes lesser here. Here dn is there, dn minus 1, dn minus 2. Now the expansion of this one is over here up to here. So plus is here. Differentiation of xy1 n times is, again by Leibniz, nc0, take the term which vanishes soon to 0 after differentiating as x, differentiation dn y1. Next is nc1, differentiation of x is 1, dn is here, dn minus 1 y1. Next minus the differentiation n times of a constant is 0, which is equal to 0. So after expanding, we will substitute the value of nc0, nc1 and then do some simplification. So first what we will do is, nc0 value is 1 itself. What is nc0 is 1. 1 into 1 plus x square as it is. Differentiation n times of y2 is, just add these two, n and 2, just add n and 2. So that is y n plus 2. Next nc1 is, it contains one term, that is n plus n, 2x as it is. What is the dn minus 1 of y2? Just add n minus 1 and 2. Just add n minus 1 and 2, you get the answer of dn minus 1 of, so n minus 1 plus 2 is, plus 2 minus 1 is plus 1. So y n plus 1 plus NC2 value is NC2 is n into n minus 1 by 2 factorial, that is 2 into 1. Next 2 as it is. What is dn minus 2 y2 is 2 minus dn minus 2 plus 2 is plus 2 minus 2 get cancelled, yn plus again now here also is there nc0 is 1 into x as it is. dn of yn is just add these two, n and 1, just add n and 1, you get n plus 1 plus nc1 value is only one term, so what you get is n, so 1 as it is. So dn minus 1 of y1 is, so you just add n minus 1 and 1, so that is n minus 1 plus 1 is n, minus 0 as it is equal to 0. Now further simplification, so we'll further simplify this. So 1 plus x square into yn plus 2 plus 2 nx yn plus 1 plus here 2 and 2 get cancels, so remaining is n into n minus 1 into yn plus x into yn plus 1 plus n into yn is equal to 0. What we get is this one. So we'll group the yn plus 2, yn plus 1 and yn separately. So we'll group, on grouping this, what we get is yn plus 2 has no term, only one term is there. Yn plus 1 has this one and one more is this one. So take the yn plus 1 common factor and group this. So what we get is 2n plus 1 into x y n plus 1 plus here yn common factor is this one, n into n minus 1 yn n. So what we get is n into n minus 1, here plus 1 is there, plus 1 into yn is equal to 0. So finally we got the expression, required expression as 1 plus x square yn plus 2, 2n plus 1 xyn plus 1 plus, so n into 1 get cancelled, n into n is n square, yn is equal to 0. This is what required.